Alright guys, so earlier this week you did like a little Desmos activity and some introductions to parent functions and transformations. So there's a resource in modules you should have clicked on earlier this week that gives you a list of all the parent functions and all the transformation rules, and that's still in there, and that's where I'm getting all of these rules from. Okay, so if you don't necessarily want to write all these down and maybe just write the examples down, you can reference that document. It's up to you, okay, but just know that's still in there. But I'll just take some time to interpret what those rules mean. Okay, so the first thing you'll see in that document are vertical translations. So vertical is up and down, right? And notice that corresponds to your rules here. I just made a note that C in that document just represents a constant, which represents a number, right? So any number. These rules are generic because it does not matter the function. Square root, log, quadratics, cubic. Okay, it doesn't matter the function. The rules stay the same. In this first couple weeks, we're just doing an overview of all your functions that you'll be studying throughout the whole year and all the transformations. Okay, and then after these first couple weeks of overview, we'll start narrowing our focus into more specifics of each function. Okay, but these rules will never change. So notice if you have a function and then a number added or subtracted on the outside of the function, the outside, okay, so outside of the function, that's what it's trying to communicate to you with this rule, on the outside of f of x. Okay, if it's a plus, it's going to move it up, minus, it goes down. So looking at this example 1, see how square root is my function, and see how that square root is just over the x. The minus 5 is not underneath the square root. It's on the outside of the function, right? So you just look at your rule and you say, oh, it's a minus, so this is going to go down 5. Okay, today in this video, I'm just showing you how to recognize it from an equation. So then you can translate that to your project. You'll start understanding how to type stuff into Desmos to make it do what you want to do. Okay, if you watch that Desmos tutorial I've already made, it shows you when you type this in, it does legitimately go down 5. Okay, but if you don't believe it, test it in Desmos, type it in, and you'll see that compared to the parent, it would move down 5. Okay, so then here we have a different function. We have log, and notice the plus 3 is not in with the x, it's on the outside, so we know it's one of these two things. It's going to be a vertical translation, and so since it's plus, we would say this would move up 3. That's it, okay, compared to the parent. Alright, so horizontal translations. Okay, so that's left and right for horizontal. Okay, notice this time the constant, the c, is not on the outside of the function, it's on the inside with the x. So inside with the x. And that's what I was hoping you would kind of discover throughout that Desmos activity. You start to see that pattern. The pattern of if the number's on the outside, it moves it up and down. If the number's on the inside, it moves it left and right. Okay, hopefully another thing you noticed in the pattern is that x's are a little different. Okay, notice if it's x minus a number, I mean your brain is trained to think your x-axis, it's positive over here and negative over here, right? Until now, with your transformation rules. Okay, so something you'll hear me say when I teach this is ex-boyfriends and ex-girlfriends are crazy. Life lessons from Miss Eka. Okay, and they're going to always do the opposite than what you think. It'll help you remember this rule. Okay, so whenever it directly affects the x, it's going to be opposite. So even though your x-axis, yes, is positive over here, to shift it to the right, you're going to use x minus a number just like this. Okay, so notice the minus 5 is on the inside with the x. That's how you know it's different than this one, and that's why I'm using the same kind of equations here so you can see the difference. So the minus 5 on the outside moves it down. The minus 5 on the inside with the x is going to shift it right. Okay, from the parent. Alright, so then here, it's directly in with the x. So your brain is thinking x-axis horizontal translation. That might help. But x's are crazy, so x plus 3 will actually move this left 3. And again, the difference here between this log of x plus 3 versus this one where the plus 3 is on the outside. So you got to start recognizing that pattern. Outside is vertical, inside's horizontal. Okay? Okay, so now let's move to reflection. So reflection is like a mirror image of the function. So here, if the negative, so reflections deal with negatives. If the negative is on the outside, that's what that's representing, in front of the function, and outside in front, it's going to reflect across the x-axis. And then here, if the negative is directly in front of the x, it will reflect across the y-axis. All right, so here, notice the negative, you just ask yourself, is it inside with the x, or is it on the outside in front? Well, it's inside with the x, so it would reflect across the y-axis. And again, if the video would let me switch from paper to computer, I would show you that in Desmos, but that's why I made a separate video showing you the Desmos and what it does. And so those of you who are super visual and need to see that reflection, make sure you watch that Desmos tutorial because I show you what it actually does. Okay, and then here, the negative in front of the whole function, so outside in front, reflects across the x-axis. All right, so those are reflections. It's all about the negatives. Okay, we're almost done. A few more to knock out. Okay, so back to vertical and horizontal. Okay, so vertical, think normal. Okay, what your brain sees is probably what's going to happen. Just like here, we saw the -5. We're like, oh, minus is down. Well, yeah, that goes down. Plus is up. Yeah, it does go up. So vertical are pretty normal. Okay, so here, with vertical stretch and shrink, this is the rule you'll see on that parent function and transformation document. So C is still a constant, just like on the other page that I did. Okay, the difference here is when C is greater than 1. And if you need to write that out in words, you're like, I don't know what that sign is, even though you need to know that. Okay, so if it's greater than 1, and it's in front of your function being multiplied to it, it's a vertical stretch. Okay, if your number, if the constant being multiplied in front, okay, so both of these are being multiplied in front, this is the rule, no matter what, okay, if the constant's being multiplied, but it's between 0 and 1, so think about numbers between 0 and 1, 1/2, 1/4, 1/8, right, fractions, in between 0 and 1, or decimals in between 0 and 1, are vertical shrinks. All right, so looking here, we've got a number in front being multiplied. That's the key here to know it's a vertical stretch or shrink. It's the number in front being multiplied. Is it bigger than 1 or between 0 and 1? Well, that's bigger than 1. It's greater than 1. Therefore, it's a vertical stretch. Okay, and again, you can type that in Desmos and see that all the y values are being stretched vertically. And if you made a t-chart, you would see the relationship there. But again, just going fast and how you can quickly do it by just recognizing it from an equation. Okay, so then here we still have a constant being multiplied in front of your function, so we know it's a vertical stretch or shrink. Okay, and because this number falls between 0 and 1, 1/3 does, that's a vertical shrink. We should put the factor, so by 1/3. So everything shrinks by 1/3. Okay, so all your y values would get multiplied by 1/3. Here, they would all get multiplied by 2. That's what makes them stretch. Okay, so now the best for last. Horizontal stretch and shrink. So horizontal, unlike vertical, okay, deal with your x's. Notice this time your constant is being directly multiplied to your x. So guess what? X's are still crazy. And they're going to do the opposite than what our brains think. Okay, so notice this. If your C, your constant, the number being multiplied directly to the x, if it's bigger than 1, it's a horizontal shrink. So it actually takes the function horizontally and compresses it, okay? And then if it's between 0 and 1, it horizontally stretches it. So it actually takes it and stretches it out horizontally. Okay, so kind of weird, kind of crazy. So, looking at this, we see that there's a number being multiplied to your x, to that variable. And so since that number is bigger than 1, it's a horizontal shrink. And if you're looking at your notes that I've attached in modules, it says how to get the factor, and it's written, both of these are by a factor of 1 over c, and what that means is the reciprocal. Reciprocal, I think I spelled that right. Okay, so the reciprocal of whatever number is in your equation. Okay, so remember, reciprocal is a fraction. You take the fraction here of the original and flip it. Okay, so here, even though that's not a fraction, we know that's 2 over 1. So it's a horizontal shrink by 1/2, because 1/2 is the reciprocal of 2, of the whole number 2. So in this equation, if you made a t-chart of the original, you would take the original x values and multiply them all by 1/2, and so therefore the function automatically shrinks in, or compresses. Okay, so here, looking, the c right here being multiplied to the x inside our function is between 0 and 1. Okay, it's bigger than 0, less than 1. So therefore it's going to be a horizontal stretch. And then we want to know by how much, what's the factor. Okay, but again, we need the reciprocal of whatever number is in the equation, whatever is being multiplied to the x. So the reciprocal of 1/2, flip that fraction, would be 2 over 1, and we can just write that as 2. Okay, so I just wanted y'all to see the difference between these two. This one's actually a horizontal shrink by 1/2, and this one's a horizontal stretch by 2. Okay, so vertical, pretty normal. Any of the rules, whether it's up and down, stretches or shrinks. Horizontal, left and right, stretches and shrinks, are crazy. Okay, they'll always do the backwards than what you think. So hopefully that kind of clarified some of those rules and maybe made more sense of that document that's in modules. Yeah, now y'all can work on your practice.